Hello, my name is Selena Sanchez, and I'm part of Makecourse Fall 2020. Today I'll be presenting Deliverable 7, which is showcasing my full project that I've been working on all semester, Behavior Doggo. Let's start with a brief overview of my control system setup. To begin with, we're going to have two pressure sensors in the front and one in the back. If the pressure sensors are pressed really hard, then the dog will move away from the user if it is less than 20 centimeters. This is done by 2 DC motors. And then if the pressure sensor in the back is pushed too hard, it'll move forward away from the user, and that is dictated by the distance sensor in the back. So now that you've seen what the dog does, let's talk about why the dog does what he does. So this idea came around with my roommates and I brainstorming at the beginning of the semester with the idea that kids with cognitive disabilities sometimes have that disconnect and aren't able to understand social cues that transcends to playing with animals. So let's say a kid comes up to a dog and pinches its ears too hard or pinches its tail too hard. That dog might have the reaction to bite or hurt the kid. And that isn't necessarily the dog's fault, but it also isn't the kid's fault because they didn't understand. So this device is to help kids make that disconnect less and understand exactly how to play with the dogs. So I'd like to show you exactly how I mounted this Behavior Doggo. To begin with, we have this little tail sensor right here, and that's going to be connected to this distance sensor, which will be located right here in the butt. I'm going to put electrical tape over it and duct tape to securely set this distance sensor into the butt. Next, I want to talk about the H-bridge. So the H-bridge is located on the back half of what we're going to call the back railing, but also the spine of the dog. And that's because that decreases the distance that the wires have to reach the motors that are located in these legs. We have the two motors on this side and on this side. Next, we have the Arduino. I put the Arduino on the top, and that's because there's more wirings running to the front of the doggo than the back of the doggo. So this Arduino is conveniently placed so that when you look at the head of the doggo, which you can see right here, he has two sensors rather than one. Okay, so next I want to look at the breadboard. The breadboard I located right here, and one key thing to note that I did not really talk about was that the Arduino power supply is very unreliable. So this port right here, and that's why I originally bought this 4 AA battery pack holder. Since it's unreliable, I had to directly wire the battery pack to the breadboard, so all the voltage and current is going through the breadboard itself. And then I had two wirings, one right here and right here, to directly connect the Arduino into it and make everything power. Ultimately, the breadboard had some sticky tape on the back, so I just popped that onto the railing. And the panelings that I printed for the Arduino and H-bridge, I just zip tied those components right in, and I also zip tied the batteries in. Here's a montage of me building Behavior Doggo, and what I'd like to note is I had to do a couple preparations, and I built this bottom piece first, I built the neck piece second, and then I also put the head piece together for the most part. And for this was just to make the assembly easier. As you can see, he assembles from the bottom up, and it's primarily best to use a vise so the distance sensors won't be pushed in or out. So let's talk about some of the assembly features within this doggo. So you have the sensors in the front, the sensor in the back that are measuring the distance, the two pressure sensors in the front on the ears, and the one pressure sensor in the back on the tail. So also you have the two motors at the bottom in the 4 wheels. So first thing to note is that the front wheels, I originally wanted to have the motor driven, but I realized that there was a lot of power from that and it kind of made it a little hard. So I decided to get rid of those motors and realized that there's enough power from the back motors to be able to run everything in the system. So I ended up taking a threaded rod that was number 10, I think, thread, and these 2 cap nuts and 2 lock nuts. And I cut the rod down to a little bit over the length of the outside of these 2 legs so I could put the cap nuts on. Also, another thing to note, when I cut it, I ended up cutting one end with the cap nut and a lock nut on, and took that lock nut and completely just unthreaded it so the threads would rethread and I could put this other cap nut on. So another thing to note is the sensors. So this one's a little wonky, and the reason being is I had to use duct tape. I didn't want to have any zip ties on the outer surface because everything else came together really cleanly. So I put the duct tape on the back to be able to push these pressure sensors up. This lost connection, but the butt end is perfectly fine. Next, I would like to point out that these wheels on the back are a little bit outwards, and that's because I didn't want to put a pulley system and just mounted those motors right on. At the end of the day, everything came out super nice. I had a couple issues with tolerances, and that was because I switched 3D printers halfway through, and that's about it. So now let's get this dog rolling. Okay, so as expressed before, this dog is based off of distance and pressure inputs. So if the distance is less than 20 centimeters and the pressure is pressed too hard, then the dog will move. Let's test that. So I have my hand less than 20 centimeters in the back sensor, and I'm pressing this thing really hard. It moves away from the user. Ultimately, we would want the user to be standing behind the dog, but for testing purposes, I'll be behind. Let's do that again for the front sensor. So here we go. It moves away. So what if the person is more than 20 centimeters away? That's going to be a good indicator that if they're more than 20 centimeters, we are going to say that the dog might be too far away and might not attack. So what we're going to do is 20 centimeters, nothing. I'm pressing it, nothing. As hard as I can go, nothing. Same thing with the back. Same thing with the back. Nothing's happening. Okay? So, what if it's less than 20 centimeters and you have a very light force? Nothing's happening. Let's go. Same with the front. That was a little too hard. Nothing. So the one issue I figured out with these pressure sensors is that they're very sensitive. So in future iterations, I would like to find something that isn't as sensitive and a little more accurate to a hard pinch. So essentially what this dog is going to do is help kids understand exactly how to play with dogs. Whether the kid presses too hard on the tail or the ear, that is a good indicator whether the dog's uncomfortable or not. And it could give cause to be able to bite a kid or something like that. So by the dog rolling away from the person who's using the device, then it's a good indicator that, hey, we probably shouldn't play that hard with the dog. In future iterations, I want to add sounds or even blinking LEDs to be able to show visual cues and auditory cues. As of right now, I'm really happy with the way that he turned out, and he works pretty well.